Welcome back. We're going to do a few more problems with Pythagorean theorem. So in this example, the missing side is not the longer side, but the theorem still works as long as you start with the hypotenuse. So this time we're looking for a leg. All right, this one is in your notes. All right, so Pythagorean theorem, hypotenuse squared, come on, come on, hypotenuse squared equals leg squared plus leg squared. And then we'll substitute. So this time our hypotenuse is 15. And the two legs are x and 9. Right, so 15 squared is 225. 9 squared is 81. Right, we're going to isolate the variable. So we'll subtract 81 from both sides. And we're only going to find the positive square root. Technically, there are two answers. However, the side of a triangle cannot be negative. So we were only going to take the positive answer. So the square root of 144 is 12. And you can add that one to your notes. And again, if you need more time, if I'm going too quickly, you can just pause me, right? Because I'm going to go on to the next problem. All right, so here we're going to solve. And so this one is not in your notes. Just follow along with me. The missing side is the blank of the right triangle. Are we missing a leg or are we missing the hypotenuse? Which one do you think it is? Well, the hypotenuse is opposite the right angle, and opposite the right angles is 9, right? Oops, see that side right there. You can't see my arrow, but there we go. That's the hypotenuse. So we are not missing the hypotenuse, we are missing the leg. All right, so when we set this up, we want the hypotenuse to be all by itself, and we're going to add up the squares of the two legs. All right, so to solve for our missing length here, we have 9 squared is equal to 6 squared plus x squared. So that's 81 is equal to 36 plus x squared. We're going to subtract 36 from both sides. So that's going to be 45. And that is not a perfect square. You're not going to give me a decimal approximation. We have to have exact answers on these. All right, so I'm going to kind of continue over here. So we will take the square root of both sides. And then over here, we're going to have to simplify our radical. So 9 and 5 divide evenly into 45. And 9 can be broken up into 3 and 3. And we see we have a pair of 3's. So 1 3 comes out, 1 3 goes away. That 5 is going to stay under the radical. So 3, because it doesn't have a body to spring it from radical prison. So 3 square roots of 5 is what x is equal to. And there, we're done with that problem. Okay? Not too difficult, right? Let's do another problem. All right, so here, what are we missing? All right, so now if we look, this up a little bit so I have a little bit more space. If we look, right across from the right angle is the side we are missing. So we are missing the hypotenuse. Right? So we always want to make sure that the hypotenuse is all by its lonesome. And we add up the squares of the legs. Right? So hypotenuse squared is going to be x squared equals, and then we'll square the other two. 36 squared plus 15 squared. Well, 15 squared I know off the top of my head, but not 36 squared so much. So I am grabbing a calculator, and fortunately there is one within my reach. And so 36 squared is going to be 1,296. And 15 squared is 225. We'll add those two together, and that'll give us 1,521. And yes, we have to simplify the radical. Maybe that's a perfect square. I don't know. Let's find out. So we'll take a square root of both sides. And so I take the square root of the x squared and the square root of 1,521. I'm going to write that over here. All right, so, well, 1 plus 5 is 6, and 6 plus 2 is 8, and 8 plus 1 is 9. So it's definitely divisible by 3, excuse me. So if you add them up and you get a number that's divisible by 3, if you add the digits up, And and that sum is divisible by 3, so is the number. So it's a divisibility rule for 3. All right, so if I divide 3 in there, I have 5. Right? And then it doesn't go into 2, but it goes into 21, and that would go 7 times. 5 plus 7 is 12. 12 is divisible by 3, so I can divide by 3 again. 3 divides into 50. Oh, 3 divides into 5, excuse me, 1 time. And then we'll have 2 leftovers here. And so 20, that would be 6. We'll have 2 more leftovers, and that would be 9. Well, 169, it's not divisible by 3, but it is 13 times 13. And so look, that was a perfect square. It just wasn't 1. That was probably immediately recognizable. So 1, 3 comes out, 1, 3 goes away, 1, 13 comes out, 1, 13 goes away. So 3 times 13, or 39, is our hypotenuse. Look at that. A perfect square there. Right? So that's our missing hypotenuse. Right? Let's solve another problem. And this one is in the notes. The safe distance of the base of a ladder from a wall it leans against should be 1/4 the length of the ladder. If it's too close, it might tip over. And then you will break your skull. So thus the bottom of a 28-foot ladder should be 7 feet from the wall. How far up the wall will the ladder reach? Right? So we have a picture here to help us figure it out. Right? We know the ladder. The ladder, notice, is forming the hypotenuse of a right triangle. And that distance from the ladder to the wall, right, is 1 leg. And then we're looking for that missing height, how far it reaches. All right, so let's set that one up. Right? So we're going to have hypotenuse squared equals leg squared plus leg squared. Right? The hypotenuse is 28. 1 leg is, we'll just call that x instead of question mark. And the other one was 7. Okay, so we'll, oops, missing a square there. We'll square those out. So 28 squared is 784. Yes, I hit the calculator with my hand before I had a chance to write it down. And this would be 49. Right, so we'll subtract 49 from both sides, and we have 735. Right? And then we'll take a square root of both sides. Right? Let's get the exact answer. And then because it's a real world problem, you often, with a real world problem, sometimes you round so it has a little bit more meaning. We'll get a decimal approximation as well. All right, so 735. Well, it's divisible by 3 because 7 plus 3 is 10 and 10 plus 5 is 15. And 15 is divisible by 3. So 3 goes in. That would go twice and, oops, 6 times, right, because that would be 13. And then 5. Well, 265 is definitely divisible by 5. All right, so 5 goes in 5 times and 53. Oh, and guess what? 53 is a prime number, so this does not simplify. Because we've got a 3, a 5, and a 53. And they're all prime numbers. So our exact answer is the square root of 735. But perhaps you want a decimal approximation because you're trying to explain it to somebody, and that doesn't have quite as much meaning for them. You say square root of 735. So our answer here, it goes up 27.1 feet. So x is approximately, right, because this is a rounded answer because it wasn't a perfect square, 27.11 feet. So the exact answer was the square root of 735. That didn't simplify, but that's approximately 27.11 feet. Okay? And so it's not too difficult to work with Pythagorean theorem. We can have a little bit trickier problems, and that's where we have some application problems. So Pythagorean theorem can also be used in figures that contain right angles. Try this. So the dimensions of a high school basketball court are 84 feet long and 50 feet wide. That single apostrophe means feet. If there were two, it would mean inches. What is the length of one corner of the court to the opposite corner? So if you don't have a picture, draw a picture, and then you can see how to set this one up. We know rectangles have 4 right angles, so that means these are both right triangles. If this side is 50, so is this side. If this side is 84, so is this side. And notice what x is opposite our right angle there. Well, we're really just looking for the hypotenuse of a right triangle, so we can use Pythagorean theorem. Right, so hypotenuse squared equals leg squared plus leg squared. And our hypotenuse is x, and one leg is 50, and the other leg is 84. 5 squared is 25, so 50 squared is 2,500. 84 squared is not a very common one, so that would be 7,056. We'll add those two together. That gives us 9,556. And then we'll take a square root of both sides. And we'll simplify the radical. And because I don't have too much space down there, I'll just work up here. Well, it's definitely divisible by 2. And that would be 4. That'd be 15, so that'd be 7. And then it'd carry 1 over, that'd be 15 again, that'd be 7. And then carry over the 1, that would be 8. Now that's divisible by 2 again. So this would be 2, and then 3, carry the 1 over, 17 would be 8, and I'd have 1 to carry over, so that'd be 9. 2,389, well, let's see. 2 plus 3 is 5. 5 plus 3 is 13, and 13 plus 9 is 22. So it's not divisible by 3, not divisible by 4, by any even numbers, not by 5. How about by 7? Not by 7. Can't be divisible by 9. If it's not divisible by 3, don't think it's divisible by 11. So this might be a prime number. I don't know. Since we haven't found anything all the way up, let's try 13. All the way up to 13, nope. We are going to call that one perhaps a prime number. 2 comes out, 2 goes away. So x is 2 square roots of 2389. If I find any more anything else that divides into 2,389, I'll let you know. But for now, I think we'll call that good as our answer. So an NBA court is 50 feet wide, and the length of one corner of the court to the opposite corner is 106.5 feet. How long is the court? So I think this one might be let's do this one as our last problem on the podcast, and I'll pick up in class on Tuesday. All right, so if it's 50 feet wide, all right, so here's our little court. We'll just call that one the width, and this one the length. And we want to find out, that's not the length. We're not given the length. We're given the corner of the court to the opposite corner, 106.5. The diagonal is 106.5. We know that's a right angle, and we're looking for how long the court is. We're looking for this. So this time we're looking for a leg. Because we have already have a decimal in our as part of one of our numbers. If this does not simplify out without any decimals, we're just going to get a decimal approximation on this one. So 106.5 squared is equal to 50 squared plus x squared. I do not know 106.5 squared. but now we do. That is 11342.25. Try to hold up the calculator here. 113, and talk in the microphone. 42.25 is equal to 2,500 plus x squared. We are going to subtract 2,500 from both sides. So we have 8842.25 is equal to x squared. And since we already have a decimal in there, let's just get a decimal approximation. So it's approximately 94.033 feet. Okay, we just took the square root of both sides. So on a problem like this, real world problem, we already have a decimal. Let's just take the decimal approximation. Okay. Well, I think this is the last problem that we'll do in this podcast, right? And then we'll pick up with some more application problems, like finding perimeter, and a problem from your notes, another perimeter, an area problem, and a few more application problems. And then we'll look at another application of Pythagorean theorem. So this is going to be the end of this podcast. Bye for now.